This is 12-2, arcs and chords. A central angle is an angle that I'm pointing to here that is formed off of the center. So it's two rays coming off of the center of the circle makes our central angle. And an arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. So in red right here would be arc AC. It's a piece of the circumference of the circle basically. And the same thing, we could also have arc CA here traveling all the way around. And the difference between these two, see they added a point because a major arc should have 3 letters. But the difference between these two is this is a minor arc, it's less than 180 degrees, and a major arc would be greater than 180 degrees. Okay, and a semicircle would be equivalent to 180 degrees. This is example 1 in 12-2. We have all of our percents of a circle, which should add to 100% if this was made correctly, and a circle has 360 degrees. So when we look at, for instance, it says find the measure of arc BC. Well, the measure of arc BC is equivalent to the central angle of 13%, but we need degrees for our angles and our arcs. So 13% is 0.13, it's 13 out of 100, what we have here, which is 13 hundredths, 0.13, times 360 degrees. So to find any of these degrees, we would take the percent, make it a decimal, and multiply it by 360 degrees. Okay, adjacent arcs are arcs that are right next to each other, like arc AB and arc BC are adjacent arcs. If you want to find the measure of the large arc formed by both of them, that is arc addition postulate. You take arc AB and you add it to arc BC, and that would give you the whole arc AC. Okay, and in this example 2 here, we're going to use arc addition postulate. We have angle BFA is 18 degrees. These are vertical angles. So angle DFE is also 18 degrees. This is 90. CFA is 180 minus 90. Okay, so for measure of arc CDE, CDE would be right here. It's 90 degrees from CD's central angle, and DE is 18 degrees because of the vertical angles here. The arc matches the central angle. 90 and 18 is 108. Okay, so there are 3 theorems here, and if we have congruent central angles, then we also have congruent chords. Okay, if we have congruent central angles, we have congruent arcs. If we have congruent chords, we have congruent arcs. If we have congruent arcs, we have congruent central angles, etc. All 3 of these are basically saying that the chords, the central angle, and the arc formed by it are all congruent. Okay, so we have RS is congruent to TU, is what they're telling us. We also know this by our congruent marks that they've placed here. So if the chords are congruent, the arcs are also congruent. So we can set these equal to each other. 3x equals 2x plus 27. We can solve for x to get 27, and we can then plug that back in to find the measure of arc RS. 3 times 27 is 81. Okay, and the same thing for if we have congruent arcs, denoted by those tick marks right there, they're telling us that the arcs are congruent, or they tell you in the words AC is congruent to DF. We can then find the measure of the angles. We know that those would be congruent as well. So 5y plus 5 equals 7y minus 43. Solve for y equals 24. Plug it back in to get measure of angle DEF, which is 125 degrees.